Hello, this is Professor Gibson. Welcome to a video for Math 114, Chapter 5, Section 2. All right, so we were talking in a previous video on for the last section about thinking of slopes, right? Slopes of lines as rates. All right, so that theme continues here really in 5.2. You see what I've written up here as a title, More Work with Lines and What They Mean. That's really kind of what the focus of this section is trying to get us to think of lines not just as math things with numbers, but as mathematical models that mean things. All right, so let's look at this. A chemical is spilled into a pond, and the concentration at this time, when the chemical is spilled, day zero, is 100 parts per million. After 10 days, the concentration is down to 0 parts per million. Assuming that the concentration is a function of days, find the slope between the two. All right. So put time in here. We're just going to crack time in days. At day zero, the concentration is 100 parts per million. At day 10, it's down to 92. Okay? So what's happening here is if we were going to write this kind of in slope-intercept form, like the t is the x and the c is the y, this would be c equals mt. All right? Plus b. Now, we're not really going to get into all of it. The question says find the slope. All right, if you remember, the slope is y2, right? M is y2 minus y1 over x2 minus x1. Or you can just think of it as the triangle means change in y or change in x. At any rate, in this case, we've got these points that we took, right? I took the words and converted them into the points in this table. So m is going to be y2 minus y1, 100 minus 0. Doggone it. 100 minus 92. There we go. Over 0 minus 10. Okay? You wanted to, I mean, you kind of want to argue with why did you put those numbers first. They just have to match up. If you wanted to, this could have been 92 minus 100 over 10 minus 0. Right? Whichever one you make 2 and whichever one you make 1, just be consistent. However we cut this, we're going to get an answer of negative 8 over 10, which is negative 0.8. All right, now my question is, what does this mean? Right, that's our question here. What does this mean? First of all, this is a slope, right? That means that since it's negative 0.8, it means for every 1 day you go forward, every one time the t goes up, or the x, whichever is the case, the t in this case goes up 1, the y, or the concentration, goes down by 0.8. And the reason you tell it goes down when the time goes up is because it's negative. Here's another thing, though. This is a real-world situation, and this is where we want to think of things as rates. When you get asked questions about word problems, this is usually helpful. As a rate, what this means is the chemical concentration, right, is going down by 0.8 parts per million per day. Okay, because the negative would be down. That's the rate, that's what it means. Okay, let's go on to the next one. Let's talk about the y-intercept and what does that mean? Every line has two key characteristics: its steepness as measured by the slope and its location. So recall the TracFone examples where we added $20 as a monthly fee, which raised the graph of the line up 20 units. So I think what we had there is we had on that TracFone something like cost equals 0.05t plus 20, and the 20 was dollars. All right, and the t was minutes, 5 cents a minute plus $20. All right. Again, there's two different ways. So I'll finish this. So We characterize the location of the line by specifying where it intercepts the y-axis. All right. Well, because of slope-intercept form, right, this number right here tells us that's the y-intercept. So in other words, the point is when t equals 0, c is going to be 20. That's the y-intercept, or the c-intercept in this case, 0, 20. What it also is, in words, is the initial value. Or in this case, it's the initial cost, right? When you haven't even used the phone a single minute, right? It's 0. Right at the beginning of the month, before you've taken a call or made a call, you're going to pay 20 bucks. It's initial cost, it's the starting cost. So the y-intercept is the initial cost, or in general, the initial value. This time it's a cost because this equation is about costs. All right. Okay, let's look at another one. Oh yeah, so this is just the same thing kind of laid out in print here. Y-intercept has two interpretations. The location of the line, right? That is, in other words, where it hits the y-axis. And the other, but in terms of when it means something in a word problem or as a model for something that's going on in the real world, it's the initial value or the starting value of the output variable. So in other words, it's the starting value for y. Starting value or initial value, same thing, different word, right? That's why for this one up here, when we were doing the cost on the track phone, the starting value, your start every month you start owing 20 bucks, right? And then it goes up from there if you use the phone. Okay. Just like in a way, in that case, you're going to pay them 20 bucks for the right to use the phone if you decide to. Okay, so let's look at the next one. A portion of road A climbs steadily for 140 feet over a horizontal distance of 2,000 feet. A portion of road B climbs steadily for 136 feet over a horizontal distance of 3,400 feet. Which road is steeper? All right, so steeper here, it's really a question about the slope. Which one has a bigger slope? Okay, now here's the other thing. We've already done our reminder. M is our slope, right? And it equals, when you've got the points, it's y2 minus y1 over x2 minus x1, right? And it doesn't really matter if those points come from, they just flat out give you numbers, right? Or if it's like in this word problem up here that we started with, if they give you the values in, in a paragraph, however you cut it, however you do it, it's the points. You've got a y and an x, or a, or in the case of the ones on the word problem there, a c and a t. Now, the other way you can do this, though, sometimes people will just call it rise over run, which is really just another way of saying, remember, this triangle here means change in y over change in x. And sometimes in a word problem like this, what you get is, you get this kind of thing here. You don't get this. That's what happened here. They're not giving us enough. We know the points. You tell us how much things change, right? All right. So let's look at A. So the slope for A, right? A is slope. Climbs steadily for 140 feet. So that means y goes up by 140, right? Climbs for 140 feet over a horizontal distance of 2,000. So y goes up 240 when x goes up 2,000. Okay, we simplify that, and we get 0, or we get 0.07 for that. Right, so it goes up 0.07 feet, if you will, for every foot it goes over. And we've also got our slope for B, and B climbs steadily 136 feet, so B goes up 136 over a horizontal distance of 3,400 feet. Okay, so now we do the division for that one, turn it into a decimal, get 0.04. Okay, so which is steeper? Well, it's the one with the bigger slope. It's this one. A is steeper. All right. Find the slope of the line passing through the given points. State whether the line is increasing, decreasing, horizontal, vertical, or undefined. All right. Slope, we're back to our y2 and y1 stuff, right? y2 minus y1 over x2 minus x1 is going to be minus 5 over 6 minus negative 2. All right. The two negatives in a row make a plus, right? So we get minus 10 over 8, which you could write that as minus 5/4, or this is also minus 1.25. All right, now, so you tell me, so this is a slope, right? Since it's a line, that means once the slope is the same everywhere. So is this increasing, decreasing, horizontal, vertical, or undefined? Well, here's what we get, right? A line is increasing, means the slope is positive. Well, that's not what this is. Decreasing means the slope is negative. Yeah, that's this one. This is a decreasing slope. Horizontal, well, that's when that's when it's vertical. I'm sorry. Horizontal means when the slope equals 0. And vertical is when the slope is undefined. Okay. Put another way, the horizontal is when the change in the y, the numerator, is 0. And the vertical is when the change in the x, the denominator, is 0. All right? So increasing, decreasing, horizontal, vertical, we'll see questions that'll ask us all of those. Last question I'm going to do here in this one. A person's salary increases by $10,725 over an 11-year period. Find the average rate of change of the salary per year. All right, so we're thinking of as a rate. Remember when they ask you for a rate like this, right? Average rate of change. A slope is a rate of change, and slope is, one of the ways to do slope is change in the y over the change in the x. In this case, the y is the money, right? So they tell us flat out the money went up by 10,725 over an 11-year period. Okay? So let's calculate it out. That is 975. So as the rate, what that means is this person's salary on average goes up $975 per year over this 11-year period. Okay, so that's the kind of thing you should expect to see. Really, it really is more about exploring, what lines and what do they mean. Okay, hope you found that helpful. Have a good week.